If you buy an anti-detect browser, you are almost certainly thinking about the browser layer, canvas noise, WebGL renderer strings, font lists, whether your time zone lines up with your IP. That is a real problem, and tools like multilogin, GoLogin, Camleo, AdsPower, and Dolphin Anti all put real engineering into solving it. I've put all 5 through their paces on this channel and on the site, but every single one of those tools stops at the browser. The second you open a checkout form on any platform, you have handed that platform a completely separate identity graph that no fingerprint profile touches, and that graph is built entirely out of your payment method. I'm Xavier Falk, and I run proxy infrastructure and cloud phones for a living. SingaporeMobileProxy.com and Cloud.one are both mine, so this isn't theory for me, it's the stuff I watch happen to real accounts every week. The accounts I've seen get clustered and killed together over the years almost never got caught on a canvas hash or a font fingerprint. They got caught because 3 supposedly separate accounts used the same card, the same PayPal email, or the same billing name on file. Payment fingerprinting is the layer anti-detect software was never built to solve, and it doesn't get talked about nearly as much as canvas spoofing does, so it's worth walking through on its own terms. Here's what payment fingerprinting actually is. When a card gets entered at checkout, the processor behind the scenes, whether that's Stripe, Adyen, PayPal, or Braintree, doesn't just authorize the charge and move on. It captures a whole bundle of data tied to that one transaction, the card's BIN, meaning the first 6 to 8 digits that identify the issuing bank and the card type, the last 4 digits, the cardholder name as type, the billing zip or address, the card's country of issuance, and very often a token that stays consistent across every single merchant using that same processor on the back end. Separately from all of that, the processor runs its own device and browser fingerprint the moment you hit the checkout button, completely apart from whatever the merchant site itself is doing. Stripe Radar, for example, fingerprints the checkout session on its own terms, with its own script, its own signals, its own risk model. So even if your anti-detect browser gives every account a unique canvas hash and a unique set of installed fonts, the payment processor's own code is fingerprinting that checkout page in parallel with visibility the merchant's own fraud team might not even have access to. PayPal takes this a step further, because it isn't just a processor sitting behind a button. It's an account system in its own right. A PayPal-funded checkout ties straight back to a PayPal login, and that login is tied to a bank account or a card on file, an identity document for any verified account, and its own long device history going back years. 2 accounts that look completely unrelated on the surface, different names, different emails, different browsers, but both get funded through the same PayPal login, are trivially linkable the moment someone looks. No fingerprinting required at all, because PayPal already knows it's the same login sitting behind both of them. This is why the card ends up being the strongest signal in the whole stack, stronger than most people expect. Browser fingerprints are probabilistic. A platform sees a canvas hash and the set of installed fonts and has to weigh how likely that exact combination is to be genuinely unique versus how likely it is to be spoofed or shared or just common across a lot of ordinary users. A card number, or even a tokenized reference to one, is deterministic. The same physical card produces the same token at the same processor every single time. No variation, no noise. So there's no ambiguity left for the platform to weigh at all. That's why card reuse is one of the fastest ways a multi-account setup gets clustered, often faster than IP overlap, faster than fingerprint similarity, faster than anything happening at the browser layer. If account A and account B both charged the same BIN, the same last 4, and the same expiry, most fraud and risk systems treat that as a near certain link, regardless of what browser, what proxy, or what device each account used to get there. Some of this signal even travels between platforms entirely, because card networks and large processors share fraud data with each other as a matter of course. Visa and MasterCard both maintain their own negative files, so a card flagged as risky on one platform can show up flagged on a completely different platform that just happens to use the same processor or subscribes to the same shared data. Picture a seller running three storefronts on the same marketplace, each one built on a separate anti-detect profile, a separate proxy, a separate device fingerprint, everything the browser layer can actually control. The moment all three storefronts get paid out to the same bank account or get topped up from the same card, the marketplace's own payment processor sees three payout destinations resolved to one underlying account almost instantly. That link gets made inside the payment rails, not in anything the browser ever presented, and it happens regardless of how good the fingerprinting on each individual profile was. A second signal that trips up otherwise careful setups is the mismatch between billing address and browsing geolocation. An anti-detect browser can set an account's apparent time zone and paired with a residential or mobile proxy, its apparent IP location too, down to the city in some cases. None of that touches the billing address on file with the card issuer or the shipping address printed on an order. If a platform checks IP-derived location against billing zip and finds them consistently mismatched across a whole batch of accounts, that mismatch is a signal on its own, completely separate from any single account's browser fingerprint. Risk teams look at this precisely because it's cheap for them to check and genuinely hard for an operator to fully align, since aligning it would mean controlling the card issuance itself, and that sits well outside anything a browser tool was ever built to touch. Card and PayPal signals rarely travel alone either. They tend to show up with company. The same cardholder name typed into 5 supposedly different accounts' billing forms is a plain text link sitting right there in a database. No analysis required to spot it. The same recovery email or the same phone number attached to a payment method is a plain text link too. No different, and it doesn't matter how carefully each account's browser profile was built if that one field ties them all back together. None of this requires any fingerprinting technology whatsoever. These are just fields that get compared directly against each other by a script that takes a fraction of a second to run. Anti-detect browsers manage the technical fingerprint of the browser session and only that. They have no mechanism for and genuinely no visibility into what a person actually types into a billing form. So this entire category of link bypasses the tool people bought specifically to avoid getting linked in the first place. So what does all of this mean for how you actually evaluate a tool? When I test multilogin, GoLogin, Camelio, AdsPower, or Dolphin Anti for the site, I'm testing exactly what they claim to test, nothing more. Whether the browser fingerprint each profile presents is internally consistent and distinct from the others, whether the time zone matches the IP, whether the WebGL renderer string matches the GPU it claims to be, whether real hardware specs leak out through side channels like audio context that most people never even check. That's a real and measurable thing to test. And in my testing, some tools genuinely do it more thoroughly and more consistently than others. But none of that testing says one single thing about whether the operator running those profiles is about to type the same card into 3 of them in a row. This is not a reason to call any of these browsers safe or legit or a scam in either direction, and I'm not going to make that call here based on something the browser was never designed to handle. It's a reason to be precise about what problem you're actually solving with the tool in front of you. A browser fingerprint tool addresses the browser fingerprint problem, and that's the whole scope of it, full stop. It does nothing for the payment layer, nothing for the account recovery layer, and nothing for the behavioral layer either. Things like typing patterns, click timing, how long a session tends to run before it converts. Platforms weigh every one of those signals too, often quietly in the background. Anyone telling you that a browser alone makes your accounts undetectable or unbannable is describing a product that simply does not exist, and I'd be lying to you if I said any different. Payment and billing data sits upstream of the browser entirely, and platforms that actually care about multi-accounting already know it's often the cheaper, more reliable signal to check first, well before they ever get anywhere near comparing canvas hashes. So here's the practical takeaway I leave you with. If you're evaluating anti-detect software for legitimate multi-account work, agency management, or your own testing, understand upfront that the browser is one layer of a much larger identity graph that platforms maintain across their whole user base. Payment processors fingerprint independently of whatever the merchant site is doing on its own. Card tokens and bins are deterministic, not probabilistic, and they get shared across merchants through consortium fraud data more often than most people assume. Billing address, cardholder name, and recovery contact details are plain text fields that get compared directly, with no fingerprinting involved at any point in that comparison. In practice, agencies that handle this well tend to treat payment identity as seriously as they treat browser identity. Separate business entities where that genuinely makes sense, separate business bank accounts and cards issued to each entity. Separate billing contacts rather than reusing one owner's personal card across every client account they manage. None of that is about evading anything. It's just basic separation of financial identity, and it's the piece most people skip because the anti-detect browser gave them a false sense that the whole identity problem had already been solved for them. A browser tool that does a genuinely good job on Canvas, WebGL, and font consistency still leaves this entire payment layer completely untouched, no matter how good it is at the job it was built for. Anyone running multiple accounts for legitimate business reasons, and that includes agencies over at multiaccountsops.com, has to plan for the payment layer as its own separate problem to solve, not as some extension of the browser problem they think they already solved by buying good software. We test these browsers hands-on, on real working setups, week after week, running actual profiles through actual checkouts and actual proxy pools rather than just reading the marketing page. We publish exactly what we find, tool by tool, including where the fingerprinting genuinely holds up and where it quietly falls apart under pressure, so you're not stuck taking a vendor's word for any of it. I test these browsers on real multi-account setups, so the written reviews and the picks I actually trust are all at antidetectreview.org. Full written reviews and tested picks at antidetectreview.org. Go take a look and subscribe if you want the next teardown the moment it lands. Nibititi Thunder. Script is 1982 words, target band 1950, 2100, 19 paragraphs. On the article itself, let me know whether to push it to Git or track it in the SEO_factory queue as published instead.